All right, welcome to week 2 for Biology 1610, Intro to Microscopes. What we are doing this week is we are teaching students how to determine the distance between tick marks on their ocular micrometer. So the ocular micrometer is basically a ruler that we can see through the lens of this ocular lens. And we don't know exactly what the tick marks on the ocular micrometer measure without calibrating it. So we have these really handy dandy stage micrometers that are calibrated to 0.01 millimeters per individual tick mark. Okay, what we mean by individual tick marks is the smallest mark between the really large numbers. So we have individual tick marks that we'll be referring to, and then numbered tick marks that we'll be referring to. The numbered tick marks are the largest tick marks. So the first measurement that I'm going to go for is at 10x. So this table here is asking students basically to calibrate their tick marks on their ocular lens, on their ocular micrometer, by using the stage micrometer. So at 10x, I'm going to measure the distance between individual tick marks and the distance between numbered tick marks, which would be a 10-fold difference between these two, by looking at the stage micrometer. So I've lined up my stage micrometer to my ocular micrometer, and they line up exactly. So I basically have two rulers. I have two rulers that have 10 tick marks, and the one on my ocular lens versus the one on the one on the ocular micrometer versus the one on the stage micrometer line up exactly in a 1-to-1 ratio, which means that the distance between numbered tick marks is 100 micrometers. Because the stage micrometer tells me on the slide itself that each individual tick mark is 0.01 millimeters, which is 10 micrometers. If you have 10 individual tick marks per numbered tick marks, you would just multiply by 10 and you'd have 100 micrometers.
Okay.
So next I want to look at the distance between individual tick marks and the distance between numbered tick marks at 40x. So I'm going to change my objective lens to 40x, and I'm going to take a look and see how my ocular micrometer and my stage micrometer line up. So I'm gonna just shift my stage micrometer, my stage micrometer just a bit so that numbers are lined up exactly. And what I see is between two numbered tick marks on the stage micrometer, the ocular micrometer goes from 1 to 9. So that's 1, 2, 3, 4, 5, 6, 7, 8 ocular micrometer numbered tick marks to 2 ocular micrometer tick marks, or 4-to-1. How would I calculate that? Well, I would say that I have 100 micrometers on my stage, because we figured that the distance between a numbered tick mark was 100 micrometers. So 100 micrometers on the stage gives you 4 numbered tick marks. Numbered tick marks on the ocular micrometer, so that would give me 25. That would give me 25 micrometers between numbered tick marks at 40x. If we divide that by 10, that's 2.5 micrometers between individual tick marks at 40x. Now, initially, I did not even calculate the diameter of the field of view at 10x because my micrometer did not go across the entire field of view. But here at 40x, when I basically zoom in, the micrometer goes across the field of view. So I can take a look at my micrometer and I can just count. I have 1, 2, 3, exactly 4 numbered tick marks on the stage micrometer, which would be 400 micrometers, which would be 0.4 millimeters. And I would just like to stress that using units is really important to stress to students. Now, in order to go from the distance between numbered tick marks to the diameter of the field of view, what we did was we multiplied, if we did ratios here, we multiplied this 25 times 25 times 16. So because all of these columns end up being ratios, like the individual tick marks are 1/10 of the numbered tick marks. The numbered tick marks end up being 1/16 of the entire length of the field of view. So here we could multiply 100 micrometers times 16, and that would give us 1600 micrometers, which would be 1.6 millimeters. Okay, and then lastly, we're going to look at the distance between, I like to start with the numbered tick marks because they're easier to see, and then I would just divide by 10 to get the individual tick marks. So I'm going to increase my magnification to 63, and then I'm going to just fine focus a little bit and move my stage micrometer so that the tick marks line up, and I can count that between one numbered tick mark on the stage micrometer, which we figured out was 100 micrometers, I have 6.5 tick marks on the ocular. So if I did the math, I would say 100 micrometers on the stage per 6.5 tick marks on the ocular, and the math adds up to 13.4 micrometers.
I think that's 15.4.
Oh, 15.4, thank you. 15.4 micrometers. And then again, this is 1/10, so it would be 1.54 micrometers for the distance between individual tick marks at 63x. And if we did our ratio here and multiplied by 16, we would get 246.2 micrometers for our diameter of field of view, which would be 0.25 millimeters. Next exercise is exploring the relationship between depth of field and magnification using our cross fibers microscope slides, where we have 3 threads lit on top of each other. We have a blue thread, a red thread, and a yellow thread. Students are going to observe the threads in focus at various magnifications. Now, before we start, we just want to bring to your attention that if you teach on redwood, the students will not be looking at the 63x. They will only be observing the threads through 10x and 40x. At Jordan campus, the microscopes start, the objective lenses start at 4x, so the students can observe from 4x, 10x, and 40x. So here at Redwood, I'm starting with a 10x magnification objective lens, and I'm looking at my threads, and I can see that all three are in focus. It seems that all three are in focus. If I zoom in or increase my magnification to 40x, now I'm going to have to back off the middle of the thread slide and play with my fine focus to see how many threads are in focus. So I backed off the middle and I'm looking at 2 threads at a time, and I can see that both red and blue are in focus together. Whereas if I look at yellow with that same fine focus, the yellow is now out of focus. So I'm going to go ahead and say that at 40x, 2 of the threads are in focus. And the idea here is that as we increase our depth of field, or as we increase our magnification, basically, if we zoom in, our depth of field decreases, which means that the thickness that we can observe in focus is smaller.